Hey guys, I hope you're all doing well. Today's lesson from space, or my kitchen table, whichever you prefer, is about transistors and how they work. You did watch the video last week about the transistor, about how important it is, like that tiny little thing. It changed the world. Without it, we would not have high-speed computers, and I can think of a million things that we wouldn't have without them. So perhaps the most important invention of the 20th century, and well, it's certainly leaning on into the 21st. Here's the schematic symbol for a specific type of transistor called an NPN transistor. Stands for negative, positive, negative, and has to do with how they are made. The real big difference between an NPN transistor and a PNP transistor, which is the other type, is that in an NPN transistor, the base here, if you power it, it will turn the transistor on. Whereas in a PNP transistor, no power means the transistor's on. It's kind of like the difference between a normally open and normally closed switch. We're not going to get too hung up on that. We're going to build the circuit with NPN transistors because, well, it's simple, and you might get asked to do both types in first year if you choose to study this at college or university. But if you can do one, it's very simple to follow the directions for the other. In any case, the transistor, this is the usual package for a small transistor. It looks like a little black kind of semicircle with a flat edge on it. The flat edge is always the front, and transistors have 3 pins. They're numbered 1, 2, and 3 when you're looking at them straight from the flat edge on. Okay, so there are collector, pin 1, base, pin 2, and emitter, pin 3. Now in the schematic diagram, an NPN transistor, the kind that we're using here called a sinking transistor, again, that's a lot of detail, but an NPN transistor always has this little arrow on the emitter facing out. A PNP transistor schematic diagram has the arrow facing in. So please make sure that the emitter or pin 3 on the schematic diagram for your transistor, which is this thing here, has the little arrow facing out on the emitter. And here is a quick Tinkercad circuits diagram of a transistor wired up to a light and a switch. And why, may you ask, is a switch, which is effectively what a transistor is, hooked up to a switch? This switch doesn't necessarily have to be a physical switch thrown by human intervention. It can be an on or off signal from an Arduino or other computer. So the advantage of this switch is that you can control it digitally by inputting a control voltage here to turn it off or on, which means that aside from having no moving parts, it doesn't require human intervention to turn it off or on. So here's the NPN transistor. In this case, I've only got one power supply, this 9-volt battery, that I'm using for both the trigger voltage at the base and the input voltage, which comes in at the collector through a light bulb. And that's because, simplicity. In this case, we have only one ground wire because both sources of power come from the same positive. So I only need one negative wire. If I were using say an Arduino to control this, or if I were using a different power supply, I would need to make sure that the grounds were all together in the circuit, that we used a common ground for both power supplies. Perhaps we'll see something like that when I do the circuit for, like, really wire a circuit, but for now we're just going to use the simulated version, and power is going to come into the circuit through the load, which is the light bulb here, to the collector of the transistor. When I don't push the button, no power reaches the base, which means that the switch is open and no power can flow between the collector and the emitter of the transistor. When I apply 5 volts, or in this case it's going to be 9, they have some tolerance transistors, and they come with different ratings and stuff, but again, for simplicity's sake, when I apply power here at the base, it's going to turn the switch on, which is going to allow power to flow right through the load, through the now closed switch, back to the negative terminal in the battery, which will allow the light to turn on. So let's see if we can watch this happen now. The simulation is started, and when I activate the push button, the light comes on. There we go. So I'm using a switch here, but this switch actually is not controlling the power that goes between the collector and emitter. It's the power that this switch allows to go to the base that is the control. So this control could come from another circuit so long as the ground is shared. All right, so here's the real thing, a circuit that I wired up. Because I don't have a bottomless supply of electronic stuff, I wasn't really prepared for teaching in a pandemic. I only have one NPN transistor at home, that's this one here. And it works exactly the same as the one in the examples, except the pin outs are different. So this one goes emitter, collector, base, and the ones in your kit go, I believe, emitter, base, collector. No, base, collector, emitter. So 1, 2, and 3 are base, collector, and emitter on yours. Just, it goes to a different pin on the transistor. Everything else works exactly the same. So here's what's in the circuit. I've got Arduino Uno for power supply just plugged into the laptop's USB port. I like to do this because the Arduino has an onboard power regulator. I've just connected the 5 volts and the ground terminals to the power rails on the breadboard, and I can set it and forget it. If I overload the Arduino, it will just shut down. If I short it, it'll just shut down. It'll save the Arduino from cooking, as well as saving all of my other electronics from getting hot, overheating, and giving me that pesky square nerd burn on my thumb, which happens quite a lot when you work with transistors like this, because if you wire it wrong, it'll not work. You'll wonder why, and you'll reach down to move it, and you will touch it with your thumb, and you will get a little square burn on your thumb. So by using the Arduino as the power supply, you don't make that impossible, but you make it a lot harder. So it's a preventative measure, and it's convenient. So I'll go with that. All right, other components here. I have a resistor. When providing current to the base of the transistor through the switch, the 5 volts from the Arduino was overloading the circuit. So I just used a good old-fashioned 10,000 ohm resistor. Brown, black, orange are the color codes on 10K. I run that into the switch, and on the other yellow line here, I go to the base of the transistor, which is pin 3 here. The power goes over here. This is the power from the power rail. It goes through the long lead, or the anode, on this LED, and then the cathode takes the power to the collector on the transistor. So when the transistor is open, power will flow between the collector, which is on this one pin 2, the middle pin, and the emitter, which on this one is pin 1, and it'll flow to ground. So right now, this normally open switch is off or open. It's not closed. There's no power going to the base, so the power that comes through from the positive side of the power supply here through the LED doesn't flow to ground. The circuit's not closed, it's not complete. When I press the button, what's going to happen is power is going to flow from the power supply through the 10K resistor and to the base of the transistor, which will turn the transistor on and allow power to flow between the collector and emitter, which will make, wait for it, the light turn on. Okay, so I hope you can see. I'm working on maybe getting a better webcam in here so that so I can zoom in a little closer for our future experiments. But hopefully this is enough combined with the other circuits you did, and you'll be able to build it. This circuit, this is what I'm asking you to build in Tinkercad. You'll be able to build this circuit in Tinkercad, take a screenshot, and hand it into the assignments folder. It's Tuesday. I hope everything's good with you guys. Have a good week, and I will speak at you soon.